Alrighty, guys, and welcome to the second Friday of NTI. And today we're going to be talking about blood and class evidence. Now, there's going to be some information on this PowerPoint that I'm not necessarily going to go over in depth, but I want you to make sure that you take a look at that. Now, in reference to that is going to be the components of blood. So there are four components of blood that I want you to make sure that you understand. So there's plasma, there's leukocytes, thrombocytes, and erythrocytes. So in terms of leukocytes, they're also known as white blood cells, thrombocytes as platelets, and erythrocytes as red blood cells. So make sure that you know the different components as well as what they do. Now, in terms of blood type distribution, so this is really how we're going to use blood as class evidence. You can see that based off of the distribution that it's going to be based off of ethnicity and as well as the blood type itself. So O positive is the most common blood type. Now, we definitely see that in terms of Latino Americans, but it's rather low for Caucasians. In terms of AB negative, however, we can see across the board that it is going to be fairly low in every single ethnicity. So AB negative is by far the most uncommon or the rarest blood type. Now, how do we use this? So I can give you a scenario. So suppose a witness identified a suspect as Caucasian. In a population of 100,000 individuals, how many people could the police narrow it down to if the suspect had AB negative blood? Now, you might be thinking, well, instead of doing that, why don't we just do a DNA test? Well, DNA tests take months in order to get that result. So if the police wanted to find a suspect as quickly as possible, we could possibly narrow it down to a smaller suspect pool. Well, if we know that the suspect is Caucasian, we can go back and look at the blood type distribution of individuals that have AB negative blood. So in terms of Caucasians, it's at 1%, so that if you have a population of 100,000 individuals, you could just simply take that 100,000, multiply it by that percent, which is going to be 0.01, which is equal to 1%, and that's going to give you 1,000 potential suspects. Now, that's not going to give you the actual suspect themselves. However, it narrows it down to a number that's much, much smaller than 990,000 individuals. So it does, you can use it as class evidence, and it is powerful in the sense of being able to narrow down the suspect pool. Now, what else could we use blood as class evidence for? Well, we can also use it for paternity testing and Punnett squares. So in this example, you can see mother's blood type and father's blood type. Mother's blood type being AO and father's blood type being OO. Now, these are numbers I had to give you, or these are letters I had to give you. So I have to give you the genotype in order to be able to determine what that paternity testing looks like. So if mother's blood type is A, father's blood type is O, you just simply do a matrix with this particular Punnett square. A comes down on both of these blocks, O comes across on all four of those blocks, O comes down on these two blocks, so that the children could be either A or O blood. There's a 50% chance for either or. Now, how does that work for the rhesus factor? So say, for instance, the mother's blood type is A positive, O negative. Father's blood type is O negative, O negative. So if an individual has a positive, the positive is dominant to the negative, so that if you have A positive, O negative, that just simply means the children will be A positive. If you have two negatives, then obviously that child is going to be O negative. Alrighty, guys, so you guys are going to have an opportunity to do different types of scenarios and different types of Punnett squares, so that if a woman gives birth to a son and claims that the man who is the father of the child refuses to acknowledge him as a son, the man claims that it is impossible for him to have fathered the child because he is A blood and the son is O blood. Is he right? Well, if we take a look at this in terms of genotypes that are given, mother's genotype is AO, father's blood type is BO or genotype. And if we look, we can see that there is a slight possibility that this individual could have fathered the child. There's a 25% chance. There's a 75% chance that he's not. So you guys are going to be doing problems just like this. If you have any questions, make sure to message me on Teams. Thanks, guys.